Good morning, ladies and gentlemen. It is an honor to be here at the second SINACON International Conference 2026. My name is Hari Adasaputra, and I am a researcher from doctoral student in Andalas University. Today, I would like to present our research entitled The Effect of Gambir Extract Fraction on the characteristic and antioxidant activity of green synthesized silver nanoparticle. Uncaria gambir, commonly known as gambir. This plant holds a very strategic position for our country, Indonesia, specifically West Sumatra. Is the main producer of gambir, supplying around 80 to 90% of global market demand. Gambir is extraordinarily rich in bioactive compounds. It possesses a wide range of pharmacological properties, including antioxidant, antibacterial, anti-cancer, and other. Previous research has shown the synthesis silver nanoparticle often tend to agglomerate. To prevent this, conventional method typically requires synthetic capping agent. However, the ethanolic extract of gambir demonstrates its true potential here, as it is rich in polyphenol and other organic compounds. These natural compounds serve a dual purpose. They act as highly effective bioreduction and capping agent to stabilize the nanoparticle, while simultaneously transferring their biological activity into final product. Method of this research. First, extraction. Gambir leaf were obtained from Balitro-lying Solok, West Sumatra. The extraction process was carried out to approach ethanol maceration and a traditional water boiling method. The fractionation process. For the fractionation process, the ethanolic extract underwent a sequential separation, result in three distinct fractions: N-hexane, ethyl acetate, and a polar fraction. Silver nanoparticle synthesis. For the silver nanoparticle synthesis, we added 2 milliliter of the 4% extract solution into 48 milliliter of 1 millimolar silver nitrate solution. This mixture was continuously stirred for 24 hours at room temperature. Afterward, the synthesis nanoparticle were characterized using UV spectrophotometer, FTIR, SRD. Finally, we evaluated all samples for their antioxidant activity. Antioxidant activity was determined using the DPPH free radical scavenging assay. The reduction of the DPPH radical was monitored by the change in absorbance for purple to yellow at 518 nanometers, with a result expressed as IC50 values. Now we enter the result and discussion section. First, look at the compound profiling using LC-HRMS to understand exactly the inside our extract and fraction. This table display the top 5 compounds identified in each sample. A highly significant find herein is the present cyanidinol or catechin, a potential polyphenol compound. As you can see, it is a most dominant compound across almost all polar and semipolar sample. including water extract, ethanol extract, ethyl acetate fraction, and the polar fraction. The synthesis nanoparticle was characterized using UV spectrophotometer in wavelength range 200 to 800 nanometer to confirm the formation of silver nanoparticle. The result UV spectrum exhibit four distinct peak at the 40 to 4 nanometer. The peak at the 400 nanometer is the characteristic peak of the silver nanoparticle. Next, we evaluate the physical characteristic of the synthesized nanoparticle using a particle size analyzer or PSA. Interestingly, both the ethanol extract and other organic fraction produce well-sized nanoparticle along with a relatively high zeta potential value, which indicate excellent colloidal stability. In contrast, the water extract yield very large particle and a low zeta potential. This strongly confirms that organic component in ethanolic extract act as much more effective capping agent. Furthermore, to determine the crystal structure of silver nanoparticle, the sample were analyzed using XRD, X-ray diffraction, to obtain the data are presented as follow. XRD analyze confirm FCC crystalline structure across all sample. To determine the presence of organic compound acting as capping agent on the silver nanoparticle, the sample were analyzed using FTIR as shown in the follow figure. FTIR spectra demonstrate successfully surface capping by distinct functional group OH, CO, CC, which vary depend on the fraction used. Did the PPH assay result reveal that silver nanoparticle synthesized using water fraction exhibit lowest antioxidant activity compared to other fraction, and were notably lower than vitamin C standard. This is like attribute to water fraction containing a lower amount of phenolic and flavonoid compound, which act as primary antioxidant. Overall, this finding indicate that the type of solvent fraction utilized in the green synthesis process significantly influence the antioxidant activity of the result silver nanoparticle. Conclusion: LCRMS analyze identify deserved second metabolite, including flavonoid and organic acid, responsible for the reduction process. UV spectroscopy confirm silver nanoparticle formation via surface plasmon resonance or SPR peak at around 400 nanometer. FTIR spectra demonstrate successfully surface capping by distinct functional group OH, CO, CC, which are independent on the fraction used. Furthermore, XRD analyze confirm FCC crystalline structure across all sample. Particle size analyzer result indicate significant size variation, range 170 to 1300 nanometer for the water extract. Antioxidant evaluation revealed the extraction solvent significantly dictate the nanoparticle bioactivity. The ethyl acetate and polar fraction exhibit the relatively high dppH radical scavenging activity. This is our reference. And this brings me to the end of my presentation. I would like to sincerely thank you for your time and kind attention today. It has been a great privilege to share our work here at the second SINACON International Conference 2026. And thank you very much.